Hello everyone, welcome back to another tip of the month. Today we're going to continue talking about digitization of information in mining, surveying, or geology. So another reason why digitizing is extremely important is to essentially use advanced methods in geology, such as geostatistics. So essentially this method requires the existence of a database from which you can extract certain information regarding your essays, your samples, etc. So in this case here, we have our diamond drill holes, and we've used composites to essentially average our samples across each diamond drill hole. So in this case, what we want to do is to develop a variogram. So with that, we're going to use the geostatistics module from ProGeox. So first thing to do is to make sure that you have your composites in the drawing. And once you have that, you can go ahead and click on the variogram command, which is located right here. So now we have our semi-variogram here on the left and the parameters to modify on the right. First thing to do is to select a layer. In this case, I'm going to keep it on the same as the composites. And here I would like to plot copper. All right, so down here in the pre-processing field, we need to input information regarding our lag. So the number of lags here, we can put that to, for example, 10. Lag size, the distance between each two, each sample here is roughly 10 units as well. The lag tolerance, I'm gonna probably put it to 3. And again, we can always test these variables once we preview. So when we click on preview, we can then essentially see our variogram. As we can see here, this is more of a, I would say, an exponential fitting model. So if I adjust the lag tolerance here a little bit more, I can see I'm gonna try and attempt to get a circular fitting method. So I think we were going to go with this data set here. So on the right hand side here, we can then select our nugget. So here we can put it to 0.1. Our contribution of the structure can go up to, I would say, 0.4. And finally, the range can be something like 20. And as you can see here, we can even adjust that a little bit more to fit our curve to match these samples here. So if we can reduce maybe this to 0.05, increase the contribution of the structure a little bit more, and maybe the range can be even more than that, like 30. So yeah, I mean, we can always play around with these values for us to finally match the data set here. And once that's done, you can essentially export this for future use. All right, so down here we have the output file name. So we can name it something like variogram test and hit save. And as we can see here now, this file here is saved in your config file. All right, it's in GST, which is the config file for geostatistics. And it's saved under the name of variogram_test.lag. So lag is the extension that we want here. And we can also export this to a CSV file. So we're gonna open our folder and have a look at this. So as we can see here in our config GST, we have all our files. And the one that we just exported is essentially found right here, variogram_test. And our CSV is with the same name, variogram_test. So let's open that file and have a look at it. So as we can see here, we have an omnidirectional method. We have the number of samples, the number of lags, the number of directions is 1, and we get also the values for each distance here. All right, so essentially this CSV can, is saved to your files and can be used in other applications as well, or to report back values. Another thing we can do is to essentially save as this semi-variogram as an image. So you can essentially export as a PNG or a JPEG, and can also be used in multiple other applications. So with that being said, this concludes our tip of the month for now. And if you have any questions, as always, please feel free to leave a comment. And thanks for watching.